This next unit in general is about quadratic equations, solving quadratic equations. How do you solve quadratic equations? You've done a lot with factoring. So how do you solve an equation like 18x squared minus 9x minus 35 equals 0? Now you've probably already talked about this in class a little bit, but first remember the key thing is we need to get this equal to 0. If your equation isn't equal to 0, you need to solve for 0. We need to get everything to one side of the equal sign. Of course, in many cases, you won't be able to combine like terms, so you're going to be creating a polynomial of some form like that. So that's the first step. First step is get equation equal to 0. Then the second step is factor. And remember, we look for a GCF first. 18 and 9, maybe we can take a 9 out of everything, but that doesn't come out of 35. 3 isn't in common either. 5, no, there's no GCF. We're going to have to go straight to splitting the middle on this one. So I want two numbers that multiply to 18 times 35, which is negative 630, and add to negative 9. Two numbers that multiply to that product, 18 times 35, and add to negative 9. Go ahead and try to figure those out. By now, if you haven't gotten it yet, be sure you pause. But the numbers are negative 30 and positive 21. Negative 30 and positive 21. Splitting the middle then gives us 18x squared minus 30x plus 21x minus 35 equals 0. Continuing to factor, I can take a 6 out of both of those. I have 6x even, 3x minus 5. And I can take a 7 out of both of those, and so I get 3x minus 5 equals 0. And so my factors are 6x plus 7 and 3x minus 5 equals 0. We factored. That's that second step. The third step is to remember the zero product property, or there's a couple different names for this idea, but it's the idea that if you have two numbers, we'll call them A and B, where A times B equals 0, that means either A or B has to equal 0. The only way, the only time you can get two numbers to multiply to 0 is if one of the numbers is 0. This is, by the way, why you always have to solve for 0. If I place that with a 6, then we don't know what A or B could be. A could be 6, B could be 1. A could be 1, B could be 6. They both could be 2 or 3. A is 2, B is 3. 1/2 and 12 would also work. 1/3 and 18. 1/10 and 60. There's actually, we have no idea what A and B would be if their product is 6. But if the product is 0, then we know necessarily that one of those two things must be 0. So set each factor equal to 0 individually, and then solve, and solve. So either 6x plus 7 equals 0, which means we can subtract 7 and get 6x equals negative 7, which means x equals negative 7 6, or 3x minus 5 equals 0. Adding 5 gives me 3x equals 5. Divided by 3, we get that x equals 5/3. So our answers, we have two of them. X equals negative 7 6, or x equals positive 5/3. There's two answers. Most of the time when you're solving a quadratic equation, you're going to end up with two answers. There's actually kind of a rule that governs that. There's a generalizable rule. The reason why we get two answers, and we have a 2 here, that's not a coincidence. In fact, there's something called the fundamental theorem of algebra. And I'm simplifying it here. You're going to be learning a lot more about this when you get to Algebra 2. But the fundamental theorem of algebra essentially says that whatever the degree of the polynomial is, you can find at most that many solutions. So if the degree of this is 5, you'll be able to find at most 5 solutions. You might only be able to find less than that, but you're never going to get more than that. If you factor in some other kind of complications, then you'll actually find that you always find exactly 5. But the issue is some of them aren't really solutions that you can find right now. I'll give you an example of that idea, just a very simplified idea. X squared plus 0, or sorry, x squared plus 1 equals 0. X squared plus 1 is a sum of squares. It doesn't factor. We can't factor it. And in fact, if you try to graph this, if you try to solve this by graphing, you'll find that the parabola shape doesn't even cross the x-axis. So there actually is no solution, at least not in the real numbers, not in the numbers that you've learned about. There's a different type of number called a complex number that you'll learn about in Algebra 2. That's how we would kind of call or give solutions to this. But the point, again, the point of the fundamental theorem of algebra is that whatever the degree of the polynomial is, that's how many solutions you should be looking for. So as another example, 10x to the 10x to the 3 minus 45x squared minus 175x equals 0. Because the degree of this is 3, we should be looking for as many as 3 solutions. So it's already equal to 0. We have that. Now we factor. And remember this. Pay attention to this fact. We can take a GCF out first. So we're going to do that. We can take out a 5x. 5x, 2x squared, minus 9x, minus 175 divided by 5 is 35, equals 0. And now we factor that. We're factoring in more than one method. We got to make sure that you follow along with this. Whatever factoring you can do, remember from the previous unit, a lot of times you can use more than one type of factoring. We got to make sure that we factor it completely. I'm going to add that. We must factor completely in order for this to work. We want it to get it equal to 0, factor it completely, and then set each factor to 0 individually and solve. So I need to factor this. So I need two numbers that multiply to negative 70 now and add to negative 9. Two numbers that multiply to negative 70 and add to negative 9. It's negative 14 and 5. Again, you should be figuring this out on your own. Don't just take my word for it. Check this out. 5x isn't going anywhere. 2x squared minus 14x plus 5x minus 35 equals 0. I can take a 2x out of those terms. 2x, I have an x minus 7. I can take a 5 out of both of those. I have an x minus 7. And that gives me 5x times 2x plus 5 times x minus 7 equals 0. So we factored completely. Now we set each factor equal to 0. Now we have 3 factors. We can say that 5x equals 0. We can say that 2x plus 5 equals 0. Or we can say that x minus 7 equals 0. 5 times x equals 0 means x, well, equals 0. 5 times 0 is 0. X minus 7 equals 0 means x equals 7. And solving this one in the middle, minus 5, we get 2x equals negative 5. And so x equals negative 5 halves. I had a polynomial of degree 3, and I end up with 3 solutions. X equals 0, x equals negative 5 halves, or x equals 7. When you're factoring, you may end up being able to pull out an x squared, or an x to the 3rd, or an x to the 4th. And so if you end up with something like this, if, for example, this had been x to the 4, to the 3, and to the 2, and so I could have taken out it's 0. So we still only end up with 3 solutions in those cases. This is what I mean. The power of 4 there means you're going to see at most that many solutions. You're not going to see more than 4 solutions. You may see as many as 4, and we could kind of count this as a solution twice. since really we could say that x equals 0, and then another x equals 0, and then 2x plus 5 equals 0, and x minus 7 equals 0, we could kind of set it up like that. But really, as many solutions as make sense given the factors that you get, that's how many solutions you should have. Most of the time you're going to end up with more than one. Sometimes you'll end up with just one, depending on if it's a special polynomial, if it's a perfect square trinomial, for example. You remember those from the previous unit. But most of the time you're going to end up with more than one solution. So just set the equation equal to 0, factor it completely using all of the different factoring methods you might need to use, and then set each individual factor equal to 0 and solve each of them individually. And those individual answers will be what we end up with as our answers to the equation.